Hello, we'll look at more probability from Algebra 2 and Trigonometry class. Alright, let's get started. So the first one here, three fair dice are tossed. Find the probability of the dice showing. Let's look at A first. At most 1, 6. What does that mean? That means we are looking at probability of having 0, 6, and probability of having a 1, 6. Now, but since this one can be done by the binomial binomial distribution, so what we can do is this. Take out your calculator, and this is what we're going to be doing. Now, first, press second bars, which is the distribution. I want you to go down a little bit. Now here, then you will see two things, binom PDF and binom CDF. Binom CDF is a cumulative binomial distribution function in a way that it collects the probability from 0 to a particular number. So for example, if I press B here, and how many times am I tossing? I'm tossing 3 times. That goes in here. What's the probability of what we are looking for happening? I want to get 6. That means it's 1 out of 6 possibility for each time. And at most, how many times am I looking at? 1. So this incorporates 0 and 1 together. Then this becomes our answer. So this basically is 92%, or 90, or rounded up around 93%. But if you have to turn this one into a fraction, you're gonna get 25 over 27. Now, so let's look at the second one. At most 2. At most 2 basically is looking probability of getting 0, 6, and then probability of getting 1, 6, and probability of getting 2 6s. So let's try to look into this one for a second, see what happens. Then once again, second distribution, and I'm gonna go for binom CDF, and 3, comma 1 out of 6, comma, now we are looking for 2 times, and most 2 times. Then we'll end up getting something like this. Now if you want to convert this one into the fraction, it will be 215 over 216. So that becomes our answer. Now, how about here? At least 2 6s. Now, at least 2, that means probability of getting 2 6s, or probability of getting 3 6s. That's the ending. But in fact, if you look at it, this is basically the opposite of the first one. So in fact, what we end up doing is 1 minus probability of getting 0, 6, and probability of getting 1/6. But this value, we calculated that earlier in part A, so this becomes 1 minus 25 over 27, which is equal to 2 over 27. That's basically what we end up getting. Now, at least one basically means probability of getting, let me put a set notation, 1, 2, 3 sixes. Oops. All of them combined together, then what's going to be happening? That's 1 minus probability of getting 0, 6. That's the same idea. So what are we going to do? One minus second distribution. I'm going to move up a little bit. In this case, I'm looking at only the first case, which is 6 coming out 0 times. So either I do CDF or PDF, it's going to be the same value. And then once again, 3, 1 out of 6, 0. That's the value that we end up getting. Or if you convert that into fraction, it was 91 over 216. Alright, let us move on to the next question. A family with 5 children is selected at random. What is the probability that the family has at least 3 boys? That means we are looking at 3 boys, 4 boys, and 5 boys. Let's try to find each one of them. Probability of having 3 boys. How do you find that? This basically means probability of getting boy must be 1/2, and then girl will be 1/2. Then in this particular case, what we're going to be happening is probability of getting boy, which is 1/2, 3 times probability of getting girl will be in fact 1/2 also. Then has to be 2, where the binomial coefficient will be out of 5. We are looking at 3 of them to be the success rate, or boys that we are looking for. And then we can calculate this one at a time, or we're going to use the calculator just like before. So here we have at least 3 boys. Then basically this means 1 minus probability of getting 0 plus probability of getting 1 plus probability of getting 2 boys. That becomes our answer. And this one we can calculate that by binom CDF. 1 minus binom CDF, and then we are looking at out of 5 children, and then 1/2 being boy, and we're gonna subtract all the possibilities up to 2. Then our answer becomes 1/2. All right. Quality control department has a department test a product and find the probability defective part is this much. And then for the 100 items, no more than 2 are defective. What does that mean? We are looking for probability of getting 0 defective. That's okay. probability of getting 1 is also okay. But more than 2 is okay, so no more than 2. That means probability of getting 2 defective product is also okay. How do you calculate this one? Once again, we're gonna calculate that by binomial CDF using 100 items, and then probably 0.001 all the way up to 2. So that's basically what we're looking for. Distribution there, and the binomial CDF out of 100 trials, where the probability of defectiveness will be 0.001, and we're looking for up to 2 defects. So then it will be this. It will be our answer. So if I were to round this one up, 0.9998. So 99.98% will be no more than 2 defectives. All right. Number 20. A landscape company will replace any shrub that they plant if it fails to grow. They estimate the probability of a failure to grow is 0.02, which means about 2%. What is the probability that out of 200 shrubs planted this week, at most 3 are replaced? At most. Then once again, cumulative, that's what we're looking at. So probability of 0 plus probability of 1 all the way up to probability of getting 3. So we're going to have the binomial CDF once again. Second distribution. Now, second, the binomial CDF, that's what we are looking for. Out of 200, and then replacement failure rate will be this much, and we're looking for at most 3 being replaced. All right, then this becomes our answer. So 0.4315, 43.15% that at most 3 will be replaced. Alright, let's look at number 8. Jack's batting average is 0.2. What is the probability that he will get 1 hit in next 3 times at bat? So that means we are looking at probability of having 1 hit. So in this case, what we can do is this. This basically means out of 3 times, we are looking only 1 time hitting. Where hitting would probability of hitting will be 0.2 to the first power. That means probability of not hitting is 0.8 to the second power. Or we can use the calculator once again. This time we have to use the binomial PDF, which is alpha A. Because what PDF does is that it gets the probability for each condition. So here, out of 3, his success ratio is 0.2, and he wants to get at least he just want to get 1 hit. Close it up. The probability of that happening is 0.384. That becomes our answer. Number 10. A fast food restaurant gives coupons for 10% off the next purchase with 1 out of every 5 purchases. Now, what is the probability that Zoe will receive the coupon with the next purchase? Now, in this case, coupon in 1 out of every 5 purchases. So that means the fact that she will get that coupon is simply 1 out of 5. It can be any one of those 5 possibilities. So just one coupon in the next 3 purchases. 3 purchases, that means we are looking at P of 1 out of 3. So then we are looking at out of 3, we are looking at 1 success, where the probability of success is 1 over 5, and probability of failure would have been not getting it, would be 4/5 to the 2nd power. Then here, if you have to calculate this one, we can do this one by hand or by calculator. Maybe we'll do both. This is equal to 3, and here we end up getting 1/5 times 16 over 25, which ends up being 48 over 125. That's by hand. Let's look at the calculator, see what happens. Once again, we have to use the binom PDF, and then we are looking out of 3. Our success ratio is 1 out of 5. And then we are looking for only 1 success. And 0.384, if you convert this one into fraction, then we get the same answer either way. Alright. And that's it. I'll see you later. Bye-bye.